Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science and Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about a brief overview on hypothesis testing. So, according to the theory of statistical inference, there may be consists of so many methods which make some inferences or generalization about the population. So, the example is the testing of hypothesis. So, for that, I'm going to introduce that. So, many of the hypothesis testing are available. So, should be make the some inferences or make generalization about the problems or the population. So, for that, I need a testing of hypothesis. So, what are the symbols I'm going to be used in hypothesis testing? So first one is H naught. So that should be representation of null hypothesis. Okay. And if I want to represent an alternative hypothesis, then I can able to make use of H1 here. And beta, Greek letter, what we can able to call. So beta here, so which is going to be a probability for committing a type 2 error. And alpha also can be called as a Greek letter. So which is going to be denote a probability of committing and type 1 error, and which should also be known as a level of significance. And under symbols what I'm going to be used is jet, and the Greek sigma should be a Greek letter, so we should be represent a variance here. And sigma x is the under symbol what I'm going to be used, so that should be a standard deviation of the sampling distribution of the mean. And mu should be a Greek letter, which means that it should be the normal population, mean of the normal population, and n should be the non-sampling size, and x will be the sampling mean, and t distribution and a standard deviation. So these are the some of the symbols I'm going to be used where in testing of hypothesis. So here we can able to use some of the symbols like H naught. So H naught is mainly meant for the null hypothesis, and H1 should be alternative hypothesis. And some other symbols like Greek letter beta, so which is going to be different types of errors are present. So let me explain in further slide, like type 1 error and type 2 error. So in order to represent this type 2 error, I've been able to make use of the beta, so for representing the probability of getting type 2 error. And alpha is the another Greek letter which is going to be represent a type 1 error, which should be also be known as level of significance. And sigma, which is going to be represent variance. So in previous video we discussed how to calculate the mean, variance and sample distribution and then all. So for this here, so for testing that we can need a testing hypothesis where we can able to represent the variance, and sigma x should be this and the variable which is going to represent the standard deviation, what we called as the mean of normal population. And it should be the sampling size, and x bar should be the sampling mean, and t should be the t distribution, and s should be the standard deviation. So these are the some of this symbols what should be applicable for testing of hypothesis. So for this hypothesis testing should be also referred to making some assumption called hypothesis about this population parameter, and then collecting the sampling data. So where you can also be make use of this calculating the sampling statistic, and may make use of this sampling statistic and also be evaluate the hypothesis to validate of our assumptions, which should be difference between the hypothesized parameter and then sampling value. So mainly this hypothesis testing is going to be first making an assumption that should be called a hypothesis about the population parameter, and second one should be collecting the sampling data and calculating sampling characteristic statistic, and make use of this statistic we can able to evaluate the hypothesis whether that should be correct or not. So normally this one should be classified in two types, like null hypothesis and alternative hypothesis. So null hypothesis means which is going to be state a hypothesized value of the parameter before the sampling, And alternative hypothesis means all the possible alternatives other than the null hypothesis is going to be considered. So where initially, suppose if I am going to have a population mean and that should be equal to 20, where it should not be not equal to 20. That is the one of the example we can able to say. Suppose if there is a no difference between the Coke and Diet Coke, and if there is a difference, then it should be alternatively hypothesis. Null. Then statistical hypothesis is the thing where it should be defined. It should be an assertion or a conjecture concern one or more populations. So where we can able to type two types of statistical hypothesis. What I said previously, that should be null hypothesis and then alternative hypothesis. So normally the statistical hypothesis is nothing but an assumption or it may be a statement. So which may or may not be true concerning one or more populations. So if I'm going to consider a population, so I can able to make an assumption that, or I can able to make a statement. So whether it may be a true population or may not be a true population. That's it. So for that, that thing is going to be classified into two types like null and then alternative hypothesis. So again, this alternative hypothesis is going to be classified into two types like normal non-directional hypothesis and directional hypothesis. So where this non-directional hypothesis means which was going to be asserts that one value is going to be different from another, and also called as two sides hypothesis. And directional hypothesis means an assertion that one measure is less than, and also called as one side hypothesis. So normally this non-directional hypothesis means that which is going to be asserts only one value, so which is going to be from one another, so also called as two side hypothesis. So like or not equal to. Direction means that this should be an assertion, so the one can able to measure it may be a less than or greater than the measure of the similar nature. So that should be called as a one side hypothesis. Okay, so this statistical hypothesis is able to define as an assertion or conjecture concerning one or more population, or I can able to define it as an assumption or it may be a statement. So which may or may not be true concerning one or more population. And this one should be of two types, what I said, a null hypothesis and alternative hypothesis. And this null hypothesis is going to be presented as H naught, and alternative hypothesis is going to be presented as H naught. Suppose if I'm going to take an example like this, suppose H naught. So here H naught means so the average number of annual income of all families in the cities is 36,000. Suppose this is the H naught I'm going to define, then H1 should be so the average annual income of all families in the city is not 36,000, should be alternative hypothesis. Okay, so one is true and another is false. Okay, so like this I can able to make an null hypothesis and alternative. Suppose if I'm going to consider another statement like if there is a no difference between the average life of brand A light bulbs and then brand B light bulbs is there. So if it is the null hypothesis, then alternative means that there should be a significant difference between brand A light bulbs and brand B light bulbs. So that means if H naught is no significant and H1 should be significant. Like this, I can able to do that. Similarly, H naught. Suppose I'm going to take a proportion of Metro Manila college students who prefer the taste of Pepsi Cola like this. The alternative should be the proportion of this Metro Manila college students who prefer the Pepsi is less than that. So here it should be greater than equal to case, but here the alternative should be either it should be less than or it should be greater than that. And similarly, suppose the proportion of the TV viewers who can able to talk shows from 9 to 10 in the evening should be Wednesday and Friday. If I'm going to consider it as a null hypothesis, then alternative should be that. So who can able to watch this people proportion should be greater than is the under case. So that should be alternative. So in null hypothesis, I'm considering so both are same on Wednesday and Friday, but I'm going to claim that in alternative hypothesis it should be greater than that. So like this, I can able to define the null hypothesis and alternative hypothesis. So normally you are going to have different types of error, what I said previously, like four possibilities of acceptance and rejection cases that may appear in the testing of hypothesis. Suppose if I'm going to consider the H0 as true and H1 is false, then when I'm going to accept the H0 and when I'm going to accept reject H0. So when I'm going to accept the H naught means that, so if this H naught is true, then outcome is true, then it should be a correct decision. If uh, H naught is false, decision what I make, if then and if that should become some the type 2 error denoted by the beta here. Suppose initial decision is accepted, but output is getting should be rejected H0, then I'm going to get type 1 error. So whatever the decision I make it correct, initially I made H1 and H0, then that should be a correct decision. Okay, so initially I make an assumption like H0, right? So for this, when I'm going to accept it, suppose if I make it as true, so the output also make it as true, then I can able to make a correct decision. Suppose H1 is false and then but reject H0, that is the case, then also the decision is correct. So when I'm going to get this type 1 and type 2 error, so this type 1 and type 2 error is going to get, so when I'm going to make accept H0 but H1 is false, okay, at that time I'm going to get type 2 error. In this case, when the type 1 error is going to get is H0 is rejected. So H0 is rejected and H0 is going to be true. So at the time I can able to get type 1 error. So all this the type 1 error is going to be represented through alpha, whereas this type 2 error is going to be represented by the symbol beta. So that means, so rejecting H0 and when H0 is true, and beta means that not rejecting H0 and H0 is false. So in those cases, we are going to get this type 1 and type 2 errors. So what are the elements of needed for testing of hypothesis? Mainly, I can able to say that that should be null hypothesis H0, and then alternative hypothesis and test statistic. So a sample test statistic is going to be used to decide whether whether we are going to reject the null hypothesis or not, and the rejection area also how much we have to be considered, and then we can also take a calculation of test statistic, and the conclusion should be a numerical value falls in rejection region or not. So these are the elements of the testing of the hypothesis. So what are the steps we have to be follow in testing of hypothesis? So for that, initially I have to formulate H0 and H1. So for any kind of population, I have to consider these two hypotheses. So first one is H0 and H1 null, and then alternative. And specify the level of significance. So what kind of level of significance I have to be considered, that should have to be specified, and then choose the appropriate test statistic. So what is the best test statistic I have to be considered, and then establish the critical region, and finally compute for the value of this test statistic and make the decision. If possible, then draw the conclusion. Okay, so these are the steps we have to be follow in testing of hypothesis. So what is this level of significance here? So for that, in order to specify the probability of committing a type 1 error, that means alpha, so which is the properly known as level of significance. Okay, to specify the probability of committing a type 1 error, so that thing should be considered as the level of significance. We can determine this critical values, which is going to be defined that the region of rejection or critical region, what I'm able to say, and then a region of acceptance. So these are the regions where we're able to determine the critical values, and these critical values should also be served as the basis for either accepting or rejecting the hypothesis. So based on the values, what I'm able to call as critical values, so based on that only I can able to decide whether the hypothesis is going to be accepted or it may be rejected. So normally the alpha region should value critical values should be 0.05, and the region of rejection should be 0.05, and the region of acceptance should be that it should be 0.95. So 0.95 should be acceptance value, critical value, and 0.05 should be rejection criteria value. And then next I'm going to discuss about two types of tests I can able to call, that should be one tail test and two tail test. Where H1 is the directional, that should be called as one tail test, and H1 is non-directional, then I can able to perform two tail test. So here one tail test means that so the region of rejection lies entirely on one end of the distribution, and the hypothesizing a range of values, whereas in two-tailed test we can able to involve in critical region where we can able to split into two equal parts placed in each tail of distribution, and a value of parameter is being hypothesized. So like this we can able to differentiate the one-tailed test and then two-tailed test. So the two-tailed test means the region of the rejection lies entirely in one end of the distribution only, and should also involve the critical region, which is going to be split into two equal parts. That thing should be one tail test. Now, two tail test, and in two tail test, what I'm going to do. So the critical regions, what I'm getting in the graph, so that should be divided into two equal parts of the distribution. Whereas in one tail test, so the region of the reaction should be entirely lies on one side only. So by seeing the graph, I can able to clearly define whether it should be one tail test or it should be two tail test. So what should be the mathematical formulation of H1? So what should be the region of rejection? I can able to say if the H1 a value is greater than that, then I can able to say that the region of rejection is placed entirely in the right tail of the distribution. If it is less than case, then the region of rejection is in the left tail only. And the not equal to the case, that means the both tails contain equal area serves as the critical region. Okay, so the here H1 should be the two cases, so whether it should be equal to case and then greater than case, and then it should be less than case. If it is greater than case, the area of rejection is placed entirely in the right tail of the distribution, and if it is less than means the region of rejection should be on the left tail there. If it is not equal to, then it should be served as the basis for both the critical regions. So by seeing this, can able to decide so whether we're going to be accept this. So I'm giving Z value and then alpha value acceptance rates. So by seeing this graph, this is one what we called as the left tail, and this is one what we called as the right tail. Suppose if the graphs should comes like this, so then this should be called as the region of acceptance. Suppose how much area is this? So by seeing this diagram, so there should be a region of rejection. Okay, so like this we can able to identify the graph. So based on that, whether how much of region is accepted and how much area of rejection is rejected, I can able to know. Suppose if I'm going to give Z is equal minus 2.3 and alpha is equal 0.1, then This should be the, then it should be the left tail, and this should be the right tail. So since I'm giving the negative value here, then so the left tail is going to be region of rejection. That should be 0.01, and this should be the region of acceptance by giving the negative value. Suppose next see that, so the critical values lies in between the plus or minus 1.96, and the alpha value is zero point 0.5. So at the time, so the region what tile lies in between the two left tile and right tiles should be the region of acceptance here, and this should be the area of rejection 0.025, and this is also the 0.025. So in this case, what I'm going to say that the critical values is lies in between the minus 1.16 to plus or minus 1.96. So based on this, can able to perform the two-tailed test. And the critical regions in testing of hypothesis, that one I can able to say, like rejecting H naught. So for this, rejecting means when I'm going to perform, suppose the computed value of Z is greater than the critical value, then I can able to perform the one-tailed test. That should be Z should be greater than Z naught. In this, that should be also same in two-tailed test. Suppose if the computed value of Z is less than the negative critical value, that means the one-tailed test that should be less than Z naught, and Z should be less than minus Z naught. So like this, we can able to be reject the H naught in testing of hypothesis, and at the same time, what type of test also I can able to perform by considering this Z naught value. Suppose if the computed value of Z should be greater than the critical value, and I can able to perform one tail test and then two tail test, and the computed value of Z is less than the negative critical value, then also I can able to perform one tail test and two tail test. So normally these are the steps what I'm going to be involved in hypothesis, like formulating the H0 and H1, that should be the main thing, and specifying the level of significance, and then choose the appropriate test statistic, and then establish the critical region and compute the value of this test statistic and make the decision and make it as a draw the conclusion also. So these are the steps what I explained now. So formulating H0 and H1 and finding how we're going to calculate the level of significance and choosing appropriate test statistic and establish the critical region by seeing the graph. So how much of region is rejected and how much of region is accepted or not. And compute the value of the test statistic and make the decision if possible. And test concerning means for normal distribution data. So how we're going to do that? So for this, so one sample test for one population. So for the sigma square, which is also known as the population variance, which is also known in unknown cases, then the population, if the sigma square is unknown, the population variance is going to be unknown here. Okay, so in one sample test, if the sigma square is known, then automatically the population variance is also known. If it is sigma square is unknown, then population variance also going to be unknown. Whereas in these two sample test cases, so the sigma 1 square and sigma 2 square is going to be known, and here it should be also equal to the sigma square, which is going to be unknown. Then I can able to perform k sample test. So these are some of the sample tests that should be concerned for the normal distribution of the data. So here some of the test hypothesis tests for the population mean. So what are the equations you have to be considered? So for H naught, if mu equal to mu naught, the test statistic equation should be delta is equal to square root of n of square root of x bar minus mu naught by x. Whereas for H, if it is greater than, then we are going to be reject H naught, and we can able to calculate this value. And if mu value should be less than mu naught, but similarly you can also be reject H naught, and the delta value should be less than that. And mu is equal to mu naught should not be equal to, then the delta value should be greater than this value. and for all n greater than them, then we can able to replace this should be the uh, value for calculating. So these are some of the sample tests for the population mean. Okay, so in this video what I'm going to cover is how we're going to perform this hypothesis testing. So what kind of symbols that is going to be needed. So this hypothesis testing is going to make some inferences generalization among the population, and the symbols what I'm going to be need for testing hypothesis should be H0, H1, and the beta is going to be committing for type 2 error, and alpha is going to be representing the level of significance, so it should be type 1 error, and the Greek letter sigma should be going to represent the mean variance, and sigma x should be the standard deviation, and Greek letter what we can able to call it as mu, that should be is going to be represent the mean of the normal population, sample size, sample mean, unit distribution, and standard deviation. And two types of hypothesis testing, what I said, that should be alternative or null hypothesis. And this statistical hypothesis is going to make an assumption or it may be a statement, so about the population, whether it may be a true or may not true. So these are some of the examples of statistical hypothesis. And two types of errors what I just explained, that is type 1 and type 2 error. So when I'm going to make the decision correct means if the null hypothesis is going to be accepted and the output should also be decision also true, then only I can able to make the decision is correct. Similarly, if the null hypothesis is going to be rejected but H1 is going to be false, then I can able to make it also that should be a correct decision. So here we're going to have two types of errors, alpha and beta. So alpha should be called as a type 1 and beta should be called as type 2. So the elements of null hypothesis should be H0, H1, and what kind of test statistics is going to be performed, and how much of rejection area have to be calculated and test statistic, and then numerical values that is going to be fall in the region of rejection. So for calculating this level of significance, the type 1 error, we can able to determine the critical values. So these critical values is going to be serves as the basis for calculating the acceptance and rejection of hypothesis. So here I can able to perform two types of tests, like one tail test and two tail test. So whenever the H1 is directional, then it should be one tail test, and whenever the H1 is non-directional, then it should be two tail test. So this is the graph what can able to perform based on the critical values. If the critical value is positive, then I have to go for the right side, right tail, and if it is less than minus value, then it should be left tail, and then two tail test should be lies in between the two things. These are the steps what I just followed.
Like, share and subscribe. Hit the bell icon for more updates.